Hello my friends and welcome to this new practical activity on multiple linear regression. So in this new section we're going to learn together how to build a multiple linear regression model on the same dataset that was introduced by Kirill in the previous lectures. And just before we start, I just want to make sure that everyone here is on the same page. This is the whole machine learning A to Z folder containing all the code and datasets. And right before this tutorial, I gave you again the link to this folder. So make sure to connect to that link. And now we should be all on the same page, ready to start this new machine learning model, which is of course in part 2, regression. And now we're going to go of course to multiple linear regression folder, and we're going to start with Python to implement this model. All right, so this is the dataset, and this is the Python implementation in IPYNB format, which you can either open with Google Collaboratory or Jupyter Notebook. Make sure you also have the folder downloaded on your machine so that you can indeed get these files. All right, so before we start the implementation, let me just explain again what this dataset is about. So remember, a venture capitalist fund hired you as a data scientist to train a machine learning model and actually a multiple linear regression model to understand the correlations between these features, which are the spend in R&D, administration, and marketing, and as well as the state, and the profit of what? Of 50 startups. So in this data set, it's very important to understand that each row corresponds to a certain startup, and for each startup, well, you data scientists collected the following data: R&D spend, administration spend, marketing spend, and the state of these startups, and of course their profit, because the goal for this VC fund is to figure out in which startup to invest based on these informations. So these are all informations that we already know from 50 startups, and therefore if you manage to train a machine learning model that can understand well these correlations, well, for the next startup you'll be able to deploy this model on these features to predict what sort of profit this new startup might generate. Okay, so for this fund you definitely want to build an accurate model. All right, and now we can start the implementation. But before we start, I would like you to figure out what are going to be the first steps of this implementation, before I show it to you. All right, so first, I hope that the first thing that came to your mind is that indeed the first step is the data preprocessing phase. And remember, in the data preprocessing phase, we start by importing the libraries, that's for sure. Then we're going to import the dataset, that's even more for sure. And then we will split the dataset between the training set and the test set, because indeed we want to train separately our model and evaluate its performance on a separate test set. Okay, so that's always required. But then, is there something else that we have to do here? Well, to answer this question, let's have a look at the columns one by one. Starting with R&D spend. So R&D spend is a numerical column, containing numerical values. And when we scroll down, we can't scroll down because there are only 50 observations corresponding to 50 startups. And we can see that here there is no missing data. So all good. Then second column, the administration spend. All the spend in administration, like paying employee salaries or anything else. So this column is once again numerical with numerical values, and there is once again no missing data. Perfect. So far our 3 steps of the data preprocessing template are good. The next one, column in marketing spend, well, same, numerical column with no missing data, all good. And now this column, the last feature, notice once again that all the features are in the first columns and the dependent variable which you want to predict in the last column. So back to this state feature, what reflex do you have in your mind now? You should have the reflex if you paid attention to part 1 data preprocessing. Basically the question I'm asking now is, do we need to apply a certain tool of our data preprocessing toolkit, which we built in part 1, into this dataset? Well, here the answer is obviously yes, because indeed this state column is non-numerical. It actually has some categories. It has 3 categories, which are New York, California, and Florida. And therefore, that's exactly the same situation as in part 1 data preprocessing. There is no order relationship between these 3 states, New York, California, and Florida. And therefore, we will have to apply one hot encoding to that state column. And therefore, we'll have to grab a tool of our data preprocessing toolkit, and that's why I prepared it here, in order to indeed one hot encode that categorical variable, the state variable. All right? And then the profit is fine. It is numerical. And besides, there is, once again, no missing data. So that's what you must do first. You need to have a look at your data set. If it is not too long, you can check that there is no missing data, like we just did. If it is too long, then I recommend to apply your data preprocessing tool that handles missing data and deploy it on this data set. And then you must check if any feature is categorical. And here we could check that very easily. The state is categorical, so we're going to apply our one-hot encoding tool of our data preprocessing toolkit on the state column. And then, of course, we will apply all the rest of the 3 essential steps of our data preprocessing template. And once again, we will do that in a flashlight because this is a template where we only have one thing to change, which is the name of the dataset.